The last application of the definite integral is consumers and the producer surplus. So let's start from the consumer surplus. Let P equals dx be the price demand equation for a product where x is the number of the unit of product that consumer will purchase at a price of P per unit. In general, you know this fact. X is the demand, P is the price. Suppose that, actually, on the other hand, what you know that? We know that the price demand equation is decreasing function. So, okay, let's show that the graph symbolically, like this one. Suppose that P bar is the current price and X bar is the number of the unit. Okay, so this is X bar. This is P bar. So P bar is the current price and X bar is the number of the unit that can be sold at the price P bar. Then the price demand curve, this curve, so this is X, this is P or D of X. Then the price demand curve shows that if the price is higher than P bar, okay, here, if the price is higher than P bar, the demand X is less than X bar. But some consumers are still willing to pay the higher price. Consumers who are willing to pay more than P bar, but who are still able to buy the product at P bar have saved money. Okay, so the consumers who are willing to pay more than P bar, these peoples, have saved money if they buy at the price P bar. We want to determine the total amount saved by all consumers who are willing to pay a price higher than P bar for the product. So, to do this, consider the interval Ck and Ck plus delta x. Okay, let's consider this interval. Where Ck delta x is less than X bar. If the price remains constant over the interval, the savings on the each unit would be difference between the delta Ck, the price consumers are willing to pay, and P bar, the price they actually pay. Since delta x represents the number of the unit purchased by consumer over the interval, the total saving to consumers over the interval is approximately this rectangle. The area of this rectangle. This is delta x. This is P. P is delta Ck. Okay. So what is this difference? delta ck minus p bar. So this area is the, dck minus p bar times delta x. Okay, here this is 7 per unit. This is number of units. Which is the area of this shaded rectangle. If we divide the interval 0 to x bar into any cool subinterval, the total saving to consumers is approximately equal to total saving approximately equals this point is C0, C1, C2, Ck. This is Cn, okay? So we divide any cool subspace like the Riemann sum. So dC1 minus P bar times delta x plus dC2 minus P bar times delta x. So this summation gives us the total saving approximately. dCn minus P bar delta x. By using the sigma notation, we can write dCk minus P bar delta x, which this summation is a Riemann sum for the integral. So when I'm going to infinity, okay, so this implies total saving exactly equals when n goes to infinity, summation from 1 to n, dCk minus P bar delta x, which is integral from 0 to x bar, d of x minus P bar dx. So this integral is the area between the graph of the dx and the y equals P bar, okay? So this area, let's sketch that area and show that here. Okay, this is y equals d of x, and that line is y equals P bar. This is x bar, this point is P bar. So this area is integral from 0 to x bar dx minus P bar dx. So this integral is defined as a consumer surplus, okay? So in the future we will not buy the shortly CAS. So this is consumer surplus. As a definition, we can conclude. That's right. If x bar P bar is a point on the graph of the price demand equation, which is P equals D of X for a particular product. For any product. Then the consumer surplus, which is denoted CS, at a price level P bar is d of x integral d of x minus P bar from 0 to x bar. Okay, which is the area between the d of x, p equals d of x, and y equals P bar. Okay, actually not y. These are the P, because x axis, y axis is P. This is P axis. This is x axis. So here this should be P. P equals delta x, and here P equals P bar. So, which is the area between P equals P bar and P equals dx from x equals 0 to x equals x bar. Okay, this is the x bar. The consumer surplus, okay, let's write. Surplus represents the total savings to consumer who are willing to pay more than P bar, for the product, but are still able to buy the product for P bar. And similarly, by using the price supply equation, we can define the producer's surplus. Producer's surplus. If P equals S of x is the price supply equation for a product, P bar is the current price, and X bar is the current supply, then some suppliers are still willing to supply some unit at a lower price than P bar. Okay, actually price supply equation is increasing, as you know, like this one. Okay, this is P equals S of x. So at the some level P bar, or at price P bar, sorry, some suppliers are still willing to supply some unit at a lower price, at that price. Okay, so the difference between the P bar and S of x, or the area between the y equals P bar or P equals P bar, because this is P axis, this is X axis. Okay, so this area is called producer surplus. Okay, so let's write definition. Everything is similar. Okay, if X bar P bar is a point on the graph of the price supply equation, P equals S of x, then the producer surplus, noted by PS, at a price level of P bar is from 0 to X bar, P bar minus S of X dx. The integral P bar minus S of X from 0 to X bar give us the producer surplus, okay, which is the area between the P equals P bar and the P equals S of X from 0 to X bar. So the producer surplus represents the total gain to producers who are willing to supply units at a lower price than P bar but are still able to supply units at P bar. So let's write the sentences. The producers surplus represents the total gain to producers who are willing to supply units at a lower price than P bar, but are still able to supply units at which price? At the price P bar.